Students, today we are going to see the important part of the second chapter in chemistry, acid, bases and salt for class 10th. In this part, we are going to learn the second part of the chapter, that is preparation of caustic soda, preparation of bleaching powder, baking soda, washing soda and plaster of Paris. Every year we expect a large number of questions. We will see large number of questions in the question papers, and this video will not only going to make this topic easy but also help you to get an idea what type of questions can be asked on this. So without wasting further time, straight away we'll start with the first one, preparation of caustic soda. Caustic soda is also known as sodium hydroxide, NaOH. It is called caustic soda because it has a caustic effect on our skin. If you put directly the concentrated sodium hydroxide on the skin, it will cause severe damage to the skin. That's what is called caustic soda. It is prepared by chlor-alkali process. Chlor-alkali process because we get an alkali, we get a chlorine in this. That's why it is called chlor-alkali process. A process in which alkali and chlorine is prepared. It is prepared by the electrolysis of dilute solution of NaCl or seawater, or it is also called brine solution, seawater solution. When you pass current through it, when you electrolyze it, we'll get three substances. First one is an alkali, sodium hydroxide. We also get hydrogen, we also get chlorine. That's why it is called chlor-alkali process. So what type of questions can be asked? A straight away question is, what is chlor-alkali process? Or second type of question is, what are the main product and byproduct of chlor-alkali process? The main product is the sodium hydroxide, the caustic soda. The byproducts are hydrogen and chlorine. The third type of question which can be asked in this exam is name the gas collected at the cathode and the anode. The gas at the cathode is the hydrogen gas. The gas collected at the anode is the chlorine gas. These are what we expect in the chlor-alkali process. The next important product which we are going to talk is the bleaching powder. Very commonly used, one of the most disinfectant commonly used disinfectant used in India, and it is chemically calcium oxychloride. Calcium oxychloride, or commonly called bleaching powder. The raw material required is, first we need a limestone. Limestone on heating will produce lime and carbon dioxide. Lime when react with water forms slake lime. When this slake lime reacts with chlorine, we'll get bleaching powder. So this is the most important part of the equation for the preparation of bleaching powder. Bleaching powder is prepared by passing chlorine gas over the dry slake lime. This is the dry slake lime, and when you pass chlorine gas, we'll get bleaching powder and hydrogen. Will get water also. Lot of questions can be asked on this. One straight away question that can be asked is that a compound X, which has a strong smell of chlorine and used as a common disinfectant, identify the substance, write the chemical equation for preparation. The compound X is the calcium oxychloride, and the preparation equation for the preparation is this. Slake lime reacting with chlorine to form bleaching powder and water. Again, this equation is very important, as it will also help you to answer some other important questions in this chapter. Is that what happened when bleaching powder is added to the water? Commonly asked question, what happened? So if you reverse this equation, there is bleaching powder is calcium oxychloride. When react with water, it gives back calcium hydroxide and chlorine gas. This chlorine gas which is liberated in the water, will kill the microorganism. That's why it is used as a disinfectant. So this is the preparation, and this is the property. What happened when bleaching powder is added to the water? Commonly asked question. The next question is that why The next very important question on the bleaching powder is that why bleaching powder should be stored in a tight container, or what happened if bleaching powder is left open, or the same question can be put, why the large scale use of bleaching powder causes air pollution. One answer for all these three questions is bleaching powder, calcium oxychloride, when exposed to air, it reacts with carbon dioxide forming CaCO3 and release chlorine gas. So when exposed to air, it combines with carbon dioxide present in the air and forms chlorine gas. So one question, one answer for three questions, why it should be stored in airtight container. If you don't store in airtight container, it reacts with carbon dioxide and loses chlorine and become ineffective. Why it should be stored in airtight container? To prevent this reaction. What happens if bleaching powder is used in excess? The chlorine gas release will cause pollution of air. So three questions are there. Then coming to the uses of bleaching powder. The bleaching powder is bleaching powder, so it can be used for bleaching. That is to remove unwanted color in textile industry and paper industry. Second, it is used in the purification of water. Third, it is used as a disinfectant for cleaning the surroundings. These are the three common uses. Now we'll move on to the next topic, that is your baking soda. Baking soda is slightly different from baking powder, and we are going to see what is different. First, baking soda, it is sodium hydrogen carbonate baking soda. Okay, it's commonly called sodium hydrogen carbonate. It is prepared by sodium solvate process. The reactants required, the common material required is ammonia, water, carbon dioxide and NaCl, the common salt. When this is reheated, we get NaHCO3 plus CO2 plus H2O. This is the main method by which baking soda is prepared. So, indirect question can be asked, a compound X of sodium, commonly used to make the pakoras crispy. A common substance of sodium X is commonly used to make the cake fluffy, soft and smooth. Identify the substance, write its preparation. It is X compound. X is sodium bicarbonate and it is prepared from ammonia, water, carbon dioxide and NaCl, and we'll get this product. From the same baking soda, we can also prepare washing soda. Washing soda is Na2CO3.10H2O, right? When this baking soda is heated, when baking soda is heated, we get washing soda Na2CO3 plus water plus carbon dioxide. We get sodium carbonate, water and carbon dioxide. But this is not washing soda. This sodium carbonate, when hydrated, when mixed with water, it will form Na2CO3.10H2O. This is called water of crystallization and this is called washing soda. This is called washing soda. Yes, this compound has two important uses. It is used in soap and detergent industry and is also used to remove the hardness of water. Okay, look at the equation. This is the equation for the preparation of baking soda. The byproduct is ammonium chloride. This is the equation for preparation of washing soda. So question can be asked, name the substance which has water of crystallization. Are the salts really dry? Such question can be asked. No, all salts won't be dry. They have some water molecules stored in it. One is such as sodium carbonate. The next one we are going to see gypsum and plaster of Paris. So the next substance which you are going to learn, the last compound, very important compound, is the plaster of Paris. Before we move to the plaster of Paris, one question which I was talking to you was what is different between baking soda and baking powder. Baking soda is sodium bicarbonate and when it is mixed with tartaric acid, it will become baking powder. It is very important to mix tartaric acid, because baking soda when used in cake at high temperature, it is converted into sodium carbonate, which will be alkaline in nature. That